Hello everybody. Time for our next lesson. We are going to continue with dividing decimals. So we'll start by putting our name and number up in the corner. Aside from some review notes, this should be it for Module 1. We are wrapping up finally. So pretty soon we'll be moving on to Module 2. Our last lesson is going to be 1-15, more dividing with decimals, because I know everybody's enjoying it. Now hopefully after the last lesson, after talking in class, you're seeing how mostly this is just the same as regular long division. The only difference is making sure that that decimal point ends up on the right spot. Now, since this is lesson 15, Roman numeral 10 plus 5 more xv. Okay, so Roman numeral 15. Now, we have some quick vocabulary. I know this vocabulary is going to be very familiar, but we need to talk about it every time to make sure that it stays familiar. Okay. Today, I'm not going to talk too much about dividend, divisor, or quotient. Hopefully you've got those. It'll come up as we're working. The big thing I want to talk about again is the difference between rounding and estimating. Now, rounding, hopefully you remember, means changing one or more numbers, changing one or more numbers, changing one or more numbers to make operations easier. In this case, the operation is going to be division. The difference between rounding and estimating is what happens afterward. After you round. Whoops. After there we go. After rounding, perform the operation. After rounding, perform the operation. There we go. Not my neatest R ever. Okay, we are going to practice today rounding with something called compatible numbers. This may not be super familiar. It's a little different than the regular rounding process we've practiced before. So follow along. We'll talk about it more in class. I know I always say that, but it's always true. Procedure, we will discuss this in class. Okay, step 1. Round the dividend. Now, on occasion, you may also, or instead of the dividend, you may round the divisor. But most of the time, you're going to want to round the dividend. It is usually a longer number, which gives you more opportunities for rounding. Especially for what we're looking at in this module, most of your divisors, the number you're dividing by, most of your divisors will be 1 digit. So you're going to want to just leave them alone. Round the dividend. Now, I know I keep repeating myself. This is where it's going to be different than the rounding we did before. With division, you want to round to a compatible number. You want to use compatible numbers. So again, what does that mean? Well, it means we're not going, mechanical pencils driving me nuts, we are not going to round using the rule, the rhyme that we learned before. Instead of doing that, we're going to take a look at our dividend which in this case, let's say that our dividend is 88 and 95 hundredths. We're going to compare that to our divisor of 9. Now, our divisor of 9 will not go into 88.95 as it normally looks. It's not going to go in this way. But if I can round this, if I can change this to a compatible number, then I can do some dividing. Now, normally I would look at this and say, round to the nearest tenth. Okay, let's get to that in a second. I want to look first at the divisor. So actually I'm going to add, let's start here. I know I was looking at the dividend, but I'm realizing let's back up. Because you want to ask yourself a question about the divisor. You want to ask, is it single digit? Is it a single digit? If the answer is yes, and it is this time, so if so, leave it. And we've talked about that. That part, at least, should probably be pretty familiar. If you're dealing with a single digit, go ahead and leave it alone. So now that I know my divisor is going to stay as 9, I want to look again at these first 2 digits. And I have a question I'm going to ask myself here. I'm going to ask, how can we change these first 2 digits, and it's almost always going to be the first 2. There are times where you just need the first 1, but really focus on the first 2. How can we change these first 2 digits into something easily? And this is the key, except I don't think there's 2 L's. Easily. How can we change this into something easily divided by this? How can we change these first 2 digits into something easily divided by 9? This is where we start thinking about our fact families. 9 times 1 is 9. 9 times 2 is 18. Times 3 is 27. So on and so on and so on, until we get to something pretty close to 88. Now, I know it can be confusing. Sometimes I say don't go over, sometimes I don't. We can go over in this case. 88 is pretty close to 90, which is a multiple of 9. It is very easy to divide by 9. Now, I could also have said, well, 88 is pretty close to 81. I can divide that by 9. Now, technically, this is closer, so this will probably give you a better estimate. However, I'm rounding up, which means my final answer, my final estimate, is going to be a little high. Sometimes that doesn't matter. Now, that is quite a step 1. But we spend all that time on that because once you have it, step 2 goes extremely quickly. All you do is divide. And if you did your rounding well, if you found a proper compatible number, then you should be able to do it mentally. Compatible just means that they go together. They fit together really nicely. So with my original problem, 88 and 95 hundredths divided by 9, I rounded this to something compatible. I rounded it to 90. Because 90 divided by 9, again, I can do that mentally. 90 divided by 9 is just going to be 10. Therefore, this is approximately equal to 10. Since that is approximately equal to 10, I've rounded, I found an answer. Looks pretty good. Now, like I said, I could have rounded over here also. If I had gone with the 81, then I would have ended up with 9 instead. So this could be approximately equal to 10 or to 9. You can see how this is getting a little tricky. And unfortunately, sometimes with rounding, we can get different numbers. 10 or 9 would both be correct in this case. I will do a few examples with you, and I'll say the reason I'm showing you both right now is because when we apply this to our long division later, not just to check an answer like we're doing right now, but when we're using it during our division, you're usually going to want to go to the one that is an underestimate, a lower estimate, even if the other one seems closer. Even if rounding up seems closer, during long division you'll want to round down. But again, we'll talk about that in class. Let's say I give you 12 and 72 hundredths divided by 3. First thing I do is look at the 3. Is that a single digit? Well, yeah. So I am going to leave it alone. I'm not going to mess with it. Then I look at these two digits and ask, can I change them into something divisible by 3? Yeah, I'll just change them into 12. I will leave them alone. I'm just dropping off the decimal. 12 divided by 3 is pretty easy. Again, if you've been practicing your facts, hopefully you know that that's 4. 12 divided by 3 is 4. So the original expression, 12 and 72 hundredths divided by 3, is approximately equal to 4. Approximately equal. We'll go ahead and do 2 more. 15 and 392 thousandths divided by 8. Okay, is that a single digit? Yes. Leave it alone. Take a look at these first 2 digits. Can I divide 15 divided by 8? Not this time. 15 divided by 8, so I'm thinking about my 8s. 8 times 1 is 8, times 2 is 16. 16 is pretty close to that. Even though I'm rounding up, right now all I'm trying to do is figure out what this expression is approximately equal to, so it's no big deal if I go up. 16 divided by 8, that's going to be approximately equal to 2. 16 divided by 8 is 2, so therefore the original expression should be pretty close to 2. Okay. Now the last one, and we're running a little low on space, but we'll squeeze it in. You should not see any like this on the test. You will not see any like this on the test. Let me say it that way. But every once in a while, you'll end up with something like this where this is not a single digit number. The divisor is not a single digit number, so I am going to want to round it also. I round to the nearest whole number, which is 5. I look at 152. I look at those first 2 digits. And 15 actually is okay. I can divide that by 5. Now there's no decimal here, so I can't just change 152 to 15. I can, however, change it to about 150. Not sure what was going on with my division there. It looks a little too much like a plus sign. Let's fix it. 150 divided by 5. Well, 15 divided by 5 is 3. And then I just have that 0 left over. So this original expression should be approximately equal to 30. And if you plug it into a calculator, you should get something pretty close. All right, ladies and gentlemen, thank you. We'll go ahead and stop there. In class, we'll practice more with compatible numbers. I'll answer any questions. And hopefully, we'll spend some more time practicing division, and you'll feel pretty confident for the test. As always, if you have questions, remember, check in with family and friends at home, check in with me at school, but make sure that you understand what's going on here. All right, that's it for today. Thank you.